So this is just the overview of everything from the compact class products all the way up to the high-end architecture class products. Uh, we do offer, low voltage products, which are 110 volt input voltage up to 690 volt three-phase. And we do have a medium voltage as well that exceeds that, but this presentation is really just tailored to the low voltage products. Everything that we're gonna touch on has the capability to be integrated into a Logix environment with Studio 5000. So, a lot of the times individuals are looking at these drives because they already have a control Logix or a compact Logix system as far as a PLC. And there are a lot of benefits that are tailored to our drives, especially the newer 520 series and the 750 series, that really pair great with the Logix system and give you a lot of benefits and a lot of cost savings. And we'll touch on all of that stuff. So in a nutshell, this is the compact class drives portfolio. So compact class is obviously on a footprint scale compact, meant to fit nice in the panel. What you see here, the PowerFlex 4M, 523, 525, 527s. These are the current active products that we have right now, right? So if you are working with a PowerFlex 4, a PowerFlex 40, PowerFlex 40P, or even the 1336 drives, legacy equipment, all of that stuff is obsolete. The 4 series drives in the 40s you could still purchase, but we are rapidly approaching the discontinued date. And once they're discontinued, it's going to be harder to get support on them. You're not going to be able to get option cards or spare parts necessarily that easy, and not to mention you're going to pay for whatever you need at that point in time. So if you're not utilizing any one of these 4 drives that you see here, you're working with outdated equipment. And it's a good idea to start to get a game plan into consideration as far as migration is concerned. So all the way on the left, we have the PowerFlex 4M. And that's kind of our most basic, simplistic volts per hertz drive. It's got a nice small compact size where it's got the capability to replace a PowerFlex 4 or a PowerFlex 40. You don't have to worry about any sort of a redesign in your panel. It's very cost effective. It's the most cost effective out of all of these drives that you see here. And it's got your typical digital input. It's a really good drive, easy to control. You have the speed pot right on the drive itself, like all the others. And this is your go-to for a very simplistic, just fan and pump application, low horsepower. As you can see, this option is only a range of 1/4 horsepower to 15. So if you're looking at anything that's 20 horsepower, 25, 30 horsepower, you're going to immediately start with the PowerFlex 520 series. So the 523s and the 525s, we're going to start with them. The 527 we'll get to, that's kind of a different animal, and we'll touch on that in a few minutes. But the PowerFlex 523, its depth on a footprint is a little bit more than the PowerFlex 4 series. So just keep that in mind when you're looking at redesigning. But the footprint is still very compact. You wall mount it or do DIN rail. zero stacking design. So you can have these drives in a panel butted up against each other. And it's really good for allowing a bunch of other space in the panel. All you need to do is make sure you have a 2-inch clearance below and above the drive, but you can zero stack them right up against each other. It's got the ability to do volts per hertz operation and sensorless vector control. And for those of you who don't know what sensorless vector control is, when we're dealing with a normal drive that's got volts per hertz, all it's doing is sending out a voltage, and it's assuming that the drive is doing what it needs to do on a mechanical standpoint. There's no real brains involved. But with the 523, you have that sensorless vector mode. And essentially what that does is it allows the drive to basically monitor each individual output phase going to the motor. And it will monitor and check for any sort of an uptick in current due to a variable load or what have you. And it will automatically adjust itself to compensate for that uptick. So you can really keep steady movement and steady speed within your application. So that's a benefit of sensorless vector control. So if you're dealing with a conveyor or any sort of application like that, you want a drive that has that feature. So our PowerFlex 520 series has sensorless vector control along with volts per hertz control. The 523 series has 5 digital inputs, I believe 2 digital outputs. Same setup on the actual drive itself as far as the start, stop, push buttons, your speed pot control. But you have the capability within there to utilize, let's say, your digital input for start stop command with a 3-wire start stop push button. It's all those basic features you could still do. Now we go on to the 525. The 525 is essentially the 523, but it's a little more advanced. So now we have all those basic features that we had just touched on with the 523. But we also have a built-in Ethernet port. So with the 523, you can still utilize Ethernet as an option, but you need to purchase a separate option card in order to install that and get your Ethernet connectivity. The 525 has that embedded right into the drive itself. Another feature that it has that really makes it a premier choice is the hardwired safety circuit that's built into the drive. Now, what this does is it takes the 24-volt internal supply from the drive and feeds it to a little relay. And that relay, factory stock, has a jumper, and that jumper obviously jumps that 24 volts over to 2 other contacts. Now, in a safety application, you would essentially remove that jumper and supply your own 24 volts to the two terminals. And whenever there is a dropout in that voltage and the drive senses that, whether it's an e-stop button or whatever, the drive is going to go into a safe torque off mode. You'll hear that referred to as STO. And what that does is it allows the drive to remain on and stay functional, but it basically turns off the IGBTs on the output end of the drive. So there is absolutely no way any torque or power can be generated from the drive to the motor. So if somebody needs to change a seal in a motor shaft, or anything that would require a quick maintenance, but it's a pain to shut down the entire system and then start it back up, that's where you would utilize your STO. So this drive has that lots of people you'll see external safety relays. And this sort of a setup eliminates the need for anything external. You all have it embedded in the drive. A couple other advanced features with this. Now we're getting into the capability of having encoder feedback. So with an option card, you can connect it in, incremental TTL 5 to 24 volt encoder and have it communicate with this drive. And now you have the capability to do closed loop PID and step logic for, a very basic positioning. I hate to even use the word positioning, more like monitoring, because this is not, a motion drive. But you do have that option, and you also have the option to utilize a permanent magnet motor. So if you ever encounter a scenario where you want to utilize an induction motor, but just the footprint is too large, well, you can switch to a permanent magnet motor, get the reduced footprint, high torque, but still utilize a VFD for the control. Now the PowerFlex 523s, the 525s, and the 527s, they're all the same footprint. They're all the same size. The 527 is a little bit different. It's got all of the features that the 525 has. But as you can see in the picture up on the top right, there's no start-stop buttons. There's no speed pop. And that's because this drive is considered a SIP drive. It's exclusively meant to work via Ethernet to a Logix controller that would support, some sort of a motion application with a kinetic system. And that's what they call premier integration with integrated motion. So it's got add-on instructions that you could download right from Rockwell Automation, and you could fit that right into a Studio 5000 environment and put this drive on a motion axis, which is really, for anybody that does like advanced configuration, that's a huge benefit right there. And instead of having one Ethernet port, now we have dual Ethernet ports. So we could daisy chain and do any sort of Ethernet topology that we need to. Not to mention, because this is a SIP drive, you can either have the hardwired STO like we had just discussed with the 525, or you can do it networked, all SIP motion or all SIP control right over Ethernet, and eliminate the need for all the hardwired cost. Now the dual Ethernet port is available as an option card for both the 523 and the 525. So if you don't need to control anything on a motion profile or anything like that, you can still buy a dual Ethernet port option card and stick it in a 525. That's totally acceptable. But you will not have the advanced safety features like you would with the 527. Now, another thing to mention with these drives is they have, at least the 520 series, they have something called ADC. It's automatic device configuration. And what that means is with either the embedded ports or the dual option cards for Ethernet ports, you have the capability to, with a Logix controller, configure one drive, install it in the system. 2 years from now, that drive may fail. Well, if you have the automatic device configuration feature selected, the PLC is going to store all of the drive parameters. And then when you remove that drive and put a new factory drive in and plug your Ethernet cable in, the PLC is going to recognize and say, hey, this is a factory drive. The parameters don't match. And it's going to automatically restore the old parameters, and you won't have to do any more configuration. So huge time saver. But once again, that's only if you're using a Control Logix or Compact Logix platform. And one other drive that we actually didn't touch on, it's actually not in here right now, but it is still active. It's the PowerFlex 400. one of our compact class drives that's specifically designed for fan, pump, and standalone applications. And it's a part of the 4 series, like the 4M, but its main benefit is it can exceed 30 horsepower. So all of these drives here max out at either 15 or 30 horsepower. The PowerFlex 400, if you're dealing with a simplistic fan application or pump application, but the pump is 100 horsepower, that's where we would utilize the PowerFlex 400. So a little more robust. It's not as compact, but it's still considered a compact class drive. So now we're going to go to the architecture class drives. Now this is a real step up in design, control, footprint, and price, right? So this is not something you would utilize for a simplistic application. This is something where there's going to be some brains involved in it, right? We'll start off with the 753s, but this is the 750 series is the latest and greatest stuff. If you're dealing with a 1336 legacy drive or a PowerFlex 700, that's old. You know, you could still get the 700s, but I believe as of 2023, they're going to be discontinued. So I get a lot of people who are coming in and requesting them. And not only are you going with an older design that's going to be outdated in a year, but you're going to be paying for it. Because like I said, once these drives get active, mature, and discontinued, the price increases. So if you're working on a PowerFlex 700 application and you want to migrate to a 750 series, you're going to notice a significant improvement in cost. So with the 753 series, this is kind of the most basic product out of the architecture class portfolio. It's got the capability to run 1 horsepower all the way up to 400 horsepower, 480 volt. You can utilize 242. This is a 6-pulse IGBT drive. So, you know, a standard kind of a setup internally. We'll get into 18-pulse drives in a little bit. It's got embedded IO 24 volt. If you're looking for 115 volt IO, then you need to purchase a separate option card that utilizes that. Along with Ethernet. If you're looking for embedded Ethernet, that's only available with your 755. The 753, you would need an option card to utilize that. This drive is what you would want to get into when you're dealing with application specifics. So, you know, whether it's a winding and unwinding application, or paper and pulp, or steel mills, you know, that's when you're going to deal with the architecture class. The 755 series is essentially the same as the 53 on a footprint standpoint. But there are a little more features available. Not only do you have great speed and torque control, like with the 753s, utilizing that sensorless vector control, but you also have position involved now. So unlike the 525 drive, where you can, you know, and communicate with an encoder, these you can communicate with an encoder, but you really have the capability to perform more positioning and motion related tasks. So a good alternative if you're utilizing a PMSM and you need, you know, accuracy, but don't want a kinetics drive for some reason. And then we get into the T series of these drives. These drives are a little different than 6-pulse. So they're designed for low harmonic applications, or regenerative applications. So the TL is something that you would typically see in a water wastewater environment where you have a 250 horsepower pump that's pumping water out right next to a residential neighborhood. The harmonics in a drive that size can significantly affect other equipment around it. So there's a standard called IEEE 519, which essentially tells you what the limitations are for that harmonic distortion. And anything that's a 18-pulse drive or an active front end drive, and that's what these drives are, active front end, it falls within that IEEE 519. And what makes it regenerative and active front end is they change the output to have IGBTs on the output, which allows you to flow unused energy back onto the line versus burning it off in, a brake resistor. So you would utilize the TR series with heavy duty downhill conveyor systems, cranes, anything that would allow for a really large heavy duty resistor. And then we also have these available in a common bus system. And you can see, they come wall mounted up to a certain frame size just based on these pictures here. I think, and after a frame 7 is when you get into the larger MCC style enclosed setups. So depending on, the horsepower and the application, you can utilize any one of these. So once again, to reiterate, if you're dealing with the PowerFlex 700, you definitely want to look into migration. You're paying too much for it, and you don't have the latest and greatest controls. We also have the PowerFlex 70. It's basically like a 753 drive. Only this one, you have the capability to have an IP66 4X rating. The 753s, you only go up to, I believe, a NEMA 3R, I think, or an IP 50. So you get the IP66 rating on this, and it's a little more compact, and a very robust drive itself. So that's the one reason they keep this drive active currently. We don't have another NEMA 4X standalone drive for the architecture class series. And this is a really useful drive here. It's a on-machine PowerFlex drive. So essentially, it's just a 525 drive as far as the guts and the logic is concerned. And the nice thing about it is you don't need a panel or anything. It's got all the quick disconnects as far as IO power, and you can mount this right to a machine. Quick wiring and installation. It's really easy to commission. Like I said, it's just a 525. It's got the capability of ADC and the integrated safety, same features. You could utilize it through Logix. So it's nice when you're dealing with sort of applications where you don't have room for a panel, but you need a disconnect and you need IO and all this stuff. Just mount it right to the side of the machine. And this is just kind of a picture that shows you with a complete ArmorFlex system how the Armor Connect cabling and everything would work. So it's mainly to reduce the installation cost and time, eliminate any sort of wiring mistakes, because now we're eliminating the screwdriver and terminal setup. and it's all just plug in. So it's a really nice setup. And this is just showing that, you know, it's available. It doesn't have the flexibility like the other drive portfolios do. It's only available in 3 frames, either 3 horsepower, 10 horsepower, or 20 horsepower. You know, if you have a 2 horsepower motor, you can utilize the 3 horsepower. That's fine. If you're upsizing a little bit, I would not exceed 50% if you're upsizing, because then you're going to get into performance issues and all that. And that's a discussion that we could take offline if anybody's got questions on that. But you either can have the standard, which is, you know, your typical 525 induction PM control, sensorless vector, disconnect IO, or you can utilize the functional safety side, which has all that stuff, but now you have safety IO included in it, and you have the capability for advanced safety, like safe speed monitoring and that sort of thing. And this is the latest offering that we have. This is the extension of the PowerFlex 750T family. Now, when the T series just came out, it was only for higher horsepower drives. And you couldn't get that sort of technology on, you know, a 5 horsepower application. Well, now, just being released as of, I believe, this month, we have the 755 TS series. So what this is it's got all your safety, SIP, security features that you would get on your normal 755. You have that total force technology, which is the capability for the, you know, crane and hoist applications and all of that, the high performance stuff, integrated into this now. And you also have the flexibility to do permanent magnet control, all of that stuff. And we get into predictive maintenance, real-time intelligence, and kind of stuff that coincides with IIoT, and really getting into the brains of preventative maintenance and predicting a bearing failure before it happens, right? So this drive now, you know, we could do that with low horsepower stuff. Not only that, but there's the capability to have a better rating. I believe that these drives are XT, which essentially means that we are now getting into corrosive gas protection, right? So IP54 rated, same operating temperatures as your standard drives, power range 1 to 400. The really nice thing about this is the corrosive gas and total force technology that you get. So the XT protection, we'll get into that a little bit. And this is something that, if requested, you can have with, you know, your regular PowerFlex 750 series. But it comes standard with this, and pretty soon down the road, it's going to be a standard feature with the 750 series as well. But what this does, and I believe that this was specifically designed to accommodate the tire and rubber industry, and there was a lot of, I guess, chemical evaporation in the air that would get into the drive guts and the components of the circuit boards and eat away at the solder and you know, basically destroy the circuit boards in there. So Rockwell went through a bunch of redesigning and implementation with some different vendors, and they redesigned the way they do their coding on their boards, right? So now we have all of these test protocols that have been done to guarantee that you're not going to experience the corrosion in those sort of environments that you would. So it's a good drive if you're dealing with you know, any sort of a high corrosive environment, even if you're sticking it in a panel, right? Because I've seen areas, whether it's a water wastewater facility where you walk in and all you smell is chlorine, and it's just, you can tell there's a lot of air contamination. And people think that it's protected just because they're in a panel, but you open up the panel and you could still see evidence of that stuff, especially if, you know, it's not getting maintained, you're not changing filters, there's not the proper ventilation in there. So like I said, eventually they're going to start doing this corrosive gas to protection to all their drives, but right now it's standard only in the ETS. And here's a perfect example, right? You can see the growth of basically contamination from these IGBTs breaching, whereas it's basically contained in here. You don't have that burnt up copper. So it just demonstrates the protection that you get when you're in that sort of an environment. Because, you know, the average lifespan for a VFD is, if treated well, 10 to 12 years, I would say. And that's if it's treated well, it's maintained, and that's average. You know, obviously we got drives that are 1336s that have been in the field since, you know, the late 90s, and they're still running, but not for long. And it's when you deal with corrosive environments, or just not even properly maintaining your drives as far as preventative maintenance is concerned, the 10 to 12 year lifespan reduces. So if you're in that sort of an environment, don't take the risk. You know, get the XT rated IGBT version, and you'll save yourself time down the road and money down the road. And that's essentially what we have as far as new product releases. So the main thing that I want to take away here is push for migration. The PowerFlex 4 applications, the PowerFlex 700 applications, the 1336s. We need to start shying away from that. If you encounter applications and you're an SI where people are requesting that, it's important to let them know this new technology is out there. You know, if you're an end user, we have some great migration benefits that we can go over offline. So, you know, just reach out to HESCO, and you know, I'll be in contact with you, and we can go over migration tasks and concerns and the whole 9 yards. But we really want to get rid of the 4 series before it's discontinued, and now we're stuck with that old equipment, right? And definitely keep in mind that we do have that Armor Flex drive on machine. It's a great option. It's often looked over, and I thought it was definitely valuable to include it in here, because a lot of people don't even realize that's on our portfolio. So yeah, once again, to reiterate, this is all going to be, you know, on social media, on YouTube. So you can go back, you could share, stream if you want to. It'll be up on LinkedIn. And, you know, we could take this time to have a little Q&A if anybody has any questions or comments. Now's the time. Perfect. Okay, it sounds like we